Good afternoon. My name is Glenn Dayton. I will be attending UC Santa Cruz next year as a computer scientist, or pursuing computer science. The name of my project that I participated in was Twisted ConText NLP Application with mentors Brian E. Chapman and Wendy W. Chapman. And this project is categorized under analysis. So the framework for today is going to be motivation for my work, such as the problems that Twisted ConText addresses and the Twisted ConText application, the thing that I created, functions such as usability, the functions of the application, and future work. So the problems that Twisted ConText addresses are medical researchers need to be able to analyze documents that clinicians create. They need to be able to see items such as the diagnosis of the patient, the current procedures that are being performed, and some of the items that are being used on with the patients. Those need to be extracted and annotated. This is better than having the researcher read individual reports. It reduces the amount of time that they have to read the reports, and it also allows the computer to categorize these, and it allows the computer to also display this in an easy, readable format. Text is not very, like a block of text is not useful for the computer. And the annotations increase the value of the clinical notes. So our goals for the application were to make the markup easy to do for a novice. So for example, the people that are going to be using the application might not have a computer background. They're people that just know how to use a basic website. So we need to accommodate for those people. We also need to create a tool that can be deployed in a variety of different ways, such as a desktop and web service. And we need to allow for customization of the tool to different users' needs. And last but not least, we need to create a tool that can be that can easily interact with other tools within the domain, so that people aren't limited to one tool. They can use a variety of different ones. So the application specifications of PyContext NLP, the actual algorithm itself takes inputs of reports and lexicon and extracts information, and the application outputs those results onto an easily readable page, and it formats the data that's taken out into structured fields so the people can read it and the computer can read it. So the user specifies the modifiers, targets, and termination terms before they actually run it. So they specify the parameters on the web page before actually running the application. And the PyContext kit application, like I said, can be deployed two different ways. The application is written based upon the Django framework. It can be deployed as a web service, as done by the intern Annie Chen in 2011, or as a standalone desktop application, my focus for the summer. And the main purpose for writing a desktop application was because of some security issues. A security issue, for example, would be that the reports and some of the other data can only be stored within an institution, and they can't distribute that through the web because of some restrictions. So this application allows the user to just take the reports within their when they're within their own firewalls and manipulate it as they wish, and provide greater flexibility and ease of use. So the function of the Twisted ConText application would be what I did this summer is I simplified the model for the lexicon. I eliminated about 4 fields from the lexicon database. One was redundant, one field was redundant, another field was it wasn't needed, and 2 fields were removed because features were removed from the application. So the footprint the database takes up is smaller but not significant. This is an interface with the Twisted service, and Twisted is a networking event-based framework for Python, in which developers can develop applications that involve networks, such as creating web pages like I did for Twisted, and there's various other functions. And another function of Twisted ConText is data and knowledge upload services, such as being able to upload the lexicon and the reports to the actual application. So that allows this tool to interact with other tools within the domain. And then running Twisted ConText with the user's desired parameters. Those are entered on the website, on the local, either on the website or on the local service. And management of reports in the annotation lexicon. You can upload the CSVs, or you can individually edit or add items to the lexicon within the page. So I'm just going to give you a little rundown as if I were a researcher and I wanted to look at some of the features on this application. So here's the home page, and the home page is duplicate to both the web and the local service. So here's the various features. Okay, so I just clicked on annotation lexicon, and this is the page that I get. So it gives me all the lexicon items, including the category, literal, and lexicon name. And I'm in the position right now where I want to add another lexicon item to the database locally on the computer. So I hit Add New Item in the red circle in the upper left-hand corner. And I am presented with this page where I get the opportunity to actually enter an item into the lexicon database. So I declare my creator name first, the label of the lexicon item. It can be any label the user desires, the category, the literal, and then the regular expression that's used to parse the information out of the reports. And integrated into this form is duplicate detection for the literal. So if a user's already entered pulmonary, it will detect that pulmonary has already been entered, and this can prevent users from entering duplicate data. So here's a page for uploading the CSV for either the report or the lexicon. As you can see, the user defines for the lexicon either if it's a domain or linguistic item. They define their label, CSV file, and for upload reports, they define the data set so they know what reports they want to use to run the application, and they choose either one that they want to upload. Okay, so I'm now at the point where I've uploaded both the reports and the lexicon items. I've possibly added more, or I've kept it where it's at. And I choose my data set. So those would be the reports that I want to run this algorithm against. And then I limit the amount of items that I want to have returned, where the limit field is, which takes an integer of the amount of items that I want returned, and the label of the lexical as determined by the name that I gave it. And then I hit run, and behind the scenes, this is what happens. So here's the processing component. I have the lexicon that has both the literal, the category, and then the regular expression. All the regular expressions are run across the report. So for example, in report, I have the word no. The words I'm interested in are no, chronic, and pulmonary embolism. So up in the lexicon, the algorithm actually looks at these regular expressions, runs it against here, determines if this is in here, and then aggregates this information into a nice, easy-to-read format. As you can see, these items both share a relationship to pulmonary embolism. So what I'm still exploring is interfacing with representation of an ontology, interfacing with evaluation workbench, interface with visualization with D3.js. What did I learn? I learned the Django framework. I already knew it, but I mastered skills, enhanced my Linux skills, and I tailored my computational career interest. I'd like to thank Professor Brian E. Chapman, Professor Wendy W. Chapman, Mike Conway, Rutu, Cal IT2, I-DBMI, and Wendy Chapman's grant. Any questions? Thank you.